Okay, Christina, now what we're going to do is go over a few of those questions that are on slide 2 of the linear motion handout. So it's the time velocity graphs, slide 3, the time velocity graphs and areas under a curve. So I'm going to look first of all at question 1. It says a car is uniformly accelerated from 10 metres per second to 40 metres per second. So here's 10, here's 40. So this is my velocity axis, the y-axis. Time axis is always on the x-axis. So this car goes from 10 to 40. I'm going to mark that on the axis in a time of 10 seconds. So it accelerates like this. It takes 10 seconds to do it. So I'm just going to mark 10 seconds on the time axis. You've got to draw a time velocity graph and find the acceleration and the distance covered. So this is the acceleration here. The distance covered will be the area underneath that line. So this is the motion line. So the distance covered will be the area, we say the area under the curve. Now, it doesn't look like a curve, but it doesn't matter, it's a line. So the area under that line. And you can see it's made up of, trying to divide it into two manageable shapes for yourself. So if I was to draw a line like this, I now have a triangle and a rectangle. So the distance, if I call the triangle A and the rectangle B, the distance would be A plus B. And all I'm doing then is finding the area of each shape. So A is the area of a triangle. So that's half the base. The base is 10 by the perpendicular height. The height of that triangle goes from 10 to 40. So its height is 30. And I'm going to add on B. B is a rectangle. So the length and the width of that is 10 by 10. And that will give me the area under that curve. So this particular bit is 5, or 2 into 10 goes 5 times. 5 by 30 is 150. Plus this is 100. So that's 250. So that's the distance that car travels is 250 metres. Now we've got to find the acceleration, so we've got to find A. So this is the next part of the question, find A. Now, we're going to use a trigonometry link here. So I'm just going to take this A bit there, put it down here, over here for a second. This is my, we'll say, y-axis. This is the x-axis. Now, a line will make a certain angle with the x-axis. So this angle here, I'm going to call it theta. That is the angle that line makes with the x-axis. So theta is the angle the line makes with the x-axis. The tan of that angle is the slope of the line. Now, the slope of this line here is the acceleration. So, the slope of the line is the acceleration. So, the tan of theta is equal to the acceleration. So, to find the tan of an angle, if I use silly old Harry link, I'm just going to draw a little, I'll do it in red, I'll do it in green. I'll draw a little right angle triangle around this. Okay, so the tan of theta would be the opposite over the adjacent. So the tan of theta is opposite over adjacent. So that's my trigonometry link, and that's equal to the acceleration. So looking at this here, that bit here, the opposite corresponds to this part of that diagram, between 10 and 40. So the opposite is 30. And the adjacent is from here to here. So in this case, the adjacent is 10. So acceleration is equal to 30 over 10, which is 3. And of course, that's metres per second squared. Okay, so that's the first question, question 1. Now let's look at question 2. Question 2, I'm going to draw an axis again. And I'm going to mark this velocity axis, meters per second, and this is the time axis in seconds. Now, from reading the question, a particle moving in a straight line is accelerated from rest by an acceleration of 4 meters per second squared, acting for 3 seconds. So from rest is from down here. So it's accelerated 4 meters per second squared, and that happens for 3 seconds. So this bit from there to there, I'm going to mark that on the axis. It then maintains a uniform velocity for 6 seconds. So it stays at constant velocity. It doesn't say what it accelerates to, so I'm just going to call that V for the time being. It maintains a uniform velocity for 6 seconds. So that distance, or that time from there to there, is 6. And then it's brought to rest again in a time of 4 seconds by uniform retardation. So down it comes here, back to rest again, and the retardation is 4 again. Draw a time velocity graph, which is this. Find the retardation and the total distance covered. Oh, sorry, I've done that wrong here. It says it's brought to rest again in a time of 4 seconds by a retardation. So I don't know that that's... So this is the retardation. I'll just call it D, deceleration. Okay, so the deceleration, I've got to find the deceleration and the total distance covered. Okay, so if I could get the slope of that line, that would be the deceleration. The slope of the line is equal to the deceleration. I'm going to mark this angle here as theta. So the tan of theta is equal to the deceleration. The tan of theta is the opposite over the adjacent. So the opposite is from the rest up to V. So that distance from there to there is V. So that's V over the adjacent is 4. That's equal to the deceleration. Right, so my first job is to find V. Okay, now I'm going to go to the other side of the graph here. And I know that the acceleration is 4, the time is 3, and this is V. So I'm going to use this triangle over here to help me find V. So that bit is 4, that bit is 3, and of course that's V. So I'm going to indicate another angle. I'll call this one here alpha. This is alpha. And I know that this is my x-axis. Here's the x-axis. So the tan of alpha is equal to the slope. The slope is 4. And to get the slope, remember, it's opposite over adjacent. So V over 3 is equal to 4, which tells me that V is 12. So that I can use this V over here now. So I'm going to use this V over here, and I'm going to say 12 over 4 is equal to deceleration. So the deceleration rate is 3 meters per second squared. Right, so that's the first part. Now I want the total distance covered. Right, so the distance covered, remember, is the area under the curve. Now, the area under the curve, let's see what that is. I'm going to divide, this is my curve here, this blue line. So I can see it's 3 obvious shapes. I can divide it into 3 obvious shapes. I'm going to call them A, B, C. And the distance is going to be A plus B plus C. So I'll add them together. A is a triangle. It's half the base is 3, by the perpendicular height, which is V. And I know what V is now, V is 12. B is a rectangle, so it's length by breadth, which is 6 by V. And 6 by V, of course, is 6 by 12. And C again is a triangle. So it's half the base is 4, by the perpendicular height, which of course is V. So this gives me 2 into 12 goes 6 3s are 18, 6 12s are 72, and this of course I said was 12, wasn't it? That V is 12. So 2 into 4 will go twice, 2 12s are 24, and I'll add all that together. 8, 2, 10, 4 is 14, carry 1, 3, 10 and 1 is 11, and that will give me 114 metres.